Assalamu alaikum warahmatullahi wabarakatuh. In the last class, we have already seen what is scalar multiplication of vector is, and it meant that stretching or shrinking the vector whenever we multiply by scalar, and if it is a positive scalar, then it is stretched or shrink in the same direction as the original vector. But if it is a negative scalar, then this shrinking or stretching occurs in the opposite direction of the original vector. Today we are going to discuss another operation, that is addition of vectors. And vector addition does not follow simple addition. It is governed by some rules or some laws, and we are going to see them. So there are two laws for vector addition. Those two laws are the same thing, but for our convenience, we say that there are two laws. We are going to see that how two vectors can be added. Consider a vector A and a vector B. To add these two vectors, we have a geometrical law, or we have two geometrical laws. We have two methods. One of them is that we take a vector, say B, this, and put the vector A in such a way that the tail of vector A touches vector B, and we have this new line which starts from the initial point of the first vector and end at the final point of the second vector, and this gives us A plus B. And remember, this addition can be performed in any order. For example, I have taken B first. In the same way, we can take vector A first and then vector B, say like this. Then again we have this as A plus B. So what we are doing here, we are completing a triangle, means we are getting a triangle. This is the method known as triangle law of addition of vectors. Triangle law of addition of vectors, and this is a geometrical method. And another thing, you can see that the order of addition does not matter. We can take B first, then add A to it, or we can reverse the order. We can take A first and add B to it. This will not change the result, and we say vector addition is commutative. Vector addition is commutative. This is one method. We have another method known as parallelogram law of addition. Parallelogram law of addition. Parallelogram law of addition. What we do here, we just take two vectors, but at this time we take vector A and we take vector B in such a way that their tails are at the same point. Then we can complete a parallelogram like this, and when it is completed, we can draw the diagonal. Let me draw it clearly. The diagonal. This diagonal, it gives A plus B, and if you can see, you can observe, then it is similar. On A, or on the head of A, we have put B, or on the head of B we have put A. So this is basically derived from the triangular law of addition. So whenever we are given two vectors, we can add them geometrically by the triangle addition law or parallelogram addition law. But if we are not adding the vector geometrically, then we have something else, and mathematically we can add vectors. How to add vectors? To understand that, let us first go into resolving a vector. What is the resolution of a vector? Now let us discuss, let us see what is vector resolution and how to resolve vectors. Suppose we have been given a vector. This is our vector. This vector is, say, vector A. Then how can, and let me name these 2 points. This is point O, our origin or initial point, and this is our final point F, OF. So we can say that we have a vector OF, and this is equal to vector A as we have shown in the figure. Now we want to resolve this vector. Resolving means to write the vector as the sum of two vectors, and remember we are dealing with a plane. So in a plane we have two things, one is length and one is width, and to resolve this vector simply means to write this vector as the sum of two different vectors. And how to do that? We just need to go from point O to F, and we can take many paths for that. Say we move here, and from here we take a second step like this. This is a vector, obviously this is a vector, and we call it A1, vector A1, this is vector A2. Then we can see that vector A is equal to vector A1 plus vector A2. This is also a kind of resolution, but it is not helpful for us. Why? Because we want to make easy our calculations, and in this I don't think that there is any easiness. So what we do, we take standard axis. Standard axis means we can say that there is, say, x-axis, and there is y-axis. When we take x-axis and y-axis, then we have a standard way of reaching from O to F. And what's that standard way is? Let me erase this. For reaching from O to F, we can first move along x-axis to a certain distance, and then we can rise here, this in y direction, ascend in y direction. The movement along x direction, say it is x meter, x units, and it is in the direction of x-axis. To denote the direction of x-axis, we use letter I with a cap. Means whenever we see I with a cap, it means the direction of vector is along x-axis. Similarly, this movement from x-axis to y-axis, from x-axis to the point F, is parallel to y-axis. So we can say that this is y and in y direction we show y direction with j cap. So we also go this another way. How? We first move this y, then we move x. It does not matter. So what we see, that vector A is the sum of two vectors, or we can go to F from point O in two steps, along x and along y. Along x axis we can move distance x or displacement x, and to show the direction we use I cap, plus along y direction distance y, and to show the direction we use j cap. So we have resolved our vector A, and one of the component is x I and the second component is y I. Now consider this angle made by x axis is theta. Then according to sine cosine rules, trigonometric ratios, what we have sine theta, and sine theta equals perpendicular by hypotenuse, and here perpendicular is y and hypotenuse is a, that is magnitude of vector A, and I have already told you that I am going to use simply A for the magnitude. Therefore we can have y equals A sine theta. Similarly, if we calculate cos theta, we have base by hypotenuse, and base is x of the triangle and hypotenuse is A. Therefore x equal to A cos theta. So if we have a vector, and any vector, say this is our vector and this is a vector named B, then we want to resolve this vector. There must be some angle made with x axis, and let this to be x axis and this is angle theta. Then the resolved part, this is, and this, these two resolved part are perpendicular because we have used x axis and y axis, along x axis and y axis, and simply we have a component along x axis, and along x axis the component is A cos theta in this case. So here along x axis the component will be B cos theta, and along y axis the component will be B sin theta. So whenever there is a vector, we can resolve it into two parts, one perpendicular component and one parallel component. One perpendicular component to the x axis and one parallel component to the x axis. And along the x axis we have cos theta. Just multiply the magnitude of the vector with cos theta, and this gives the vector in x direction or component in x direction along x axis, and if we multiply the magnitude with sin theta, then it gives the component along y axis. That is, these are the two perpendicular components of a vector, and we will use perpendicular components because it will help us in several ways and in several calculations. If we have understood this, then we can move further to calculate the we can add two vectors mathematically, and what we have already done before geometrically. So let us proceed, let us move ahead.